Assalamualaikum and hello, my name is Irfan Iqbal bin Muhammad Asri, and I will explain about the introduction of our project. Okay, we use a bicycle as our kinematic rigid body to monitor the rotation and the movement of the bicycle wheel at a certain position, as well as the velocity of an acceleration using Newton's second law of motion, which is F equal to ma. A rigid body is an idealization of a body that cannot change shape and may be defined as a bunch of the particles with the same space between particle during the body motion. However, the presumption that the body did not change is quite strong, since the distance between every pair of particles must remain constant. Then there are three types of kinematic rigid body properties. And first, translation, rectangular and curvilinear, the motion in which all lines in the body remain parallel to the same point. These motions points all share the same velocity and acceleration. Second, the motion body that dictated by an angular velocity of the rotation, which is all the particle moving a circular route about the axis of rotation, is rotating along the fixed axis. And last, 3, any plane of motion that is neither a translation nor a pure rotation falls into a category, yet a general plane motion may be reduced to the sum of rotation and translation. Okay, next. Linear and angular stiff body posture axis, a vector of quality equal to the time rate change in the linear position for linear velocity. Motion with no rotation has some relative velocity at the very point on the rigid body, but when motion has rotation, the instantaneous velocity of any point on the body is no longer the same. The body point will have the same instantaneous velocity if they are on a axis parallel to the instantaneous axis of a rotation. Meanwhile, angular velocity is defined as a vector number that represents the angular speed of a rigid body when its orientation change and the instantaneous axis around which it is spin. Okay, for our objective for this project, we want to apply the study kinematic of rigid body in reality. Next, we want to find the rotation and movement of bicycle wheel at a certain point, to determine the velocity and acceleration by using this Newton's second law of motion, which is F equal to ma. For to study about the friction force value can be effect when the mass is changed. And last, to apply all equation and formula related to our project application.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azri Azim bin Mat Razali. My number metric is DD217. So today I will be presenting about case study. My case study is about bicycle, and to summarize, bicycle and motorcycle dynamics is the motion signs of their component due to force acted on them. Dynamic force under branch physics such as classical mechanics, including balancing, steering, braking, accelerating, suspension, activation, and vibration. So it's broad and quite complex, so we put in more liabilities to only research about the velocity, the acceleration, the rigid body of kinematic, and then also the slope calculation for friction and gravity. So an object will rest at state, or object at constant velocity will stay at constant velocity unless an act upon an unbalanced force. This law applies to the steep slope of the hills and the various terrain that mountain biking consists require a design that compensate for this factor. So for bike that going uphill can be considered 5 of the factor. The firstly are forces that consider a single system. The forces component can divide into two, internal and external. The external force is all the masses gravity pulls the rider and all the bike component toward the earth. So the tire contact patch there are horizontal and vertical component. So the internal forces are those between the component of the bike and the rider system that caused by friction. The mass balance is the bike remains upright when it's straight, so the combination of bike and cyclist can balance the internal and external force. The forward speed that applies torque handlebars in order to turn the front wheel, so the control to lean and maintain balance while overcoming wind resistance. So next is the methodology. The methodology we put the cyclists going uphill and while maintaining their stability and catching the changes force due to the angle of surface. As the slope increase, the decrease of the pulling force due to gravity into the component parallel and perpendicular to the surface. Okay, so as the incline increase, the component change drastically, and which produce a force pull the object down due to gravity, which is why it feels harder to pedal up and incline, because the additional force that has been to overcome in order to progress. So the weight, the normal force, air resistance, friction, and unknown force toward the bike of the road. This is the formula that we'll use in the calculation after this, so we can complete our objective for our problem statement. Next is the experiment results. So the experiment result, we can only conduct to the case studies physically because we are unable to, so we carry out theoretically analysis. Based on the figure, 3 cyclists of different mass are placed at the beginning of the plane. As it move up 5% grade incline for 100 meter horizontally, movement 25 meter upward movement. This is why we apply kinematic of rigid body and calculate the velocity and acceleration accordingly. That's it all for my presentation. Thank you.
My name is Khairul Arif Muhammad Ifin, and my metric number is DD20080. For the calculation condition, the calculation has 2 sections, each with a different angle. One is 2.680, the other is 14.036, although they both have the same horizontal B 100 meter. To calculate the normal force, acceleration, and velocity, first of all, we assume that the bicycle and the person itself is equal to the box. As a reminder, this is not how it should be calculated, but the concept is still the same in every condition. So first of all, we need to draw the free body diagram to see the force that acting on the box, which is in our case is in inclined plane. In an equation, first of all, we use the Newton law of motion, which is F equal to ma. In the y-axis is equal to 0 because there is no motion, but in the x-axis it is equal to ma because there is a motion. So that's where we come from to find the acceleration. So to find the velocity, we use the kinematic equation, which is equal to v square equal with v initial square plus 2a distance. But in our case, the distance that we know is the horizontal, the b. To find the distance, we use the law cosine because we know B is 100 meter in both cases. In the first case, the degree is 2.680 and we can find it C is 100.1 meter. In the second case, the degree is 14.03 and we can find it C is 103.08 meter. So after we added all the value into the equation, we get the result. For the normal force in the first cases, we get it is higher than the second cases. And the illustration show that the first cases is positive and the second case is negative. And the same goes for the velocity. For the summary analysis, normal force, when we increase the mass, the normal force will be increasing. If we increase the angle of the inclined plane, in our case, the hill, it will decrease the normal force. As for the acceleration and velocity, theoretically, in our calculation, show that the acceleration will decrease if the mass is increased. So if the cyclist is heavier, it will need more force to cooperate with the lighter cyclist. So the increasing the angle also reduce the acceleration and velocity.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Hakim Zambri and I will talk about the discussion. The key reason for this case study is we may get the simple yet compact data, namely for the normal force, acceleration, velocity, and the kinetic energy. It is a comprehensive experiment that is relatively simple to research. The main goal for this case study is to use the kinematics of the rigid body formula to compute the acceleration of the rigid body during the rotation of movement of the bicycle wheel at a certain point. The final goal is to define the vector number that represent the angular speed of the rigid body when its orientation changes and the instantaneous axis around which it spin. We had to specify several parameters for this case study, as I previously mentioned. To begin with the plane inclination, adjust to 2.680 and the 14. We had a 2 inclination, which is 2.680 and 14.036. In order to find the magnitude, the acceleration, and the velocity of the three bikes, we set their mass to 75 kg, 80 kg, and 100 kg, respectively, and assume that the plane was frictionless. The magnitude of the acceleration is 0.263 meter per second, or 0.263 meter per second, 0.213 meter per second, and 0.063 for the acceleration. And for the velocity is 52.653, 42.643, and 14.613 according to the calculation for the first slope. And the magnitude for the second slope, the magnitude of acceleration for the second slope is negative 1.655 meter second, 1.705, and negative 1.705, and negative 1.855. And the velocity for the second slope is negative 341.195, negative 351.503, and negative 382.427 according to the second slope calculation. For the investigation for this investigation, it is suggest that for the tire or wheel that use that for use is used for the aluminium or the carbon fiber as a property for any good bike frame material to avoid any accidents. Assalamualaikum warahmatullahi wabarakatuh. Okay, as a conclusion, we may conclude that the case study and the calculation that changing the mass of the object has no effect of the value of the velocity and acceleration. In the case study of a kinetic energy, however, we may deduce that the greater of the item mass, the more kinetic energy will be stored inside the object, even at the constant acceleration and velocity. Furthermore, the total impulse of the that occur during the time period can be influenced by the mass of the object. Because of the mass growth, the inclination becomes steeper and the surface becomes smoother. As the result, the greater mass of the object will have the higher impulse value than the lower masses. Plus, we also compare three discrete points, where the discrete point with the object rolling down inclined plane recombination. As the result, we can see the velocity and the acceleration differences between each point to the original distance. Thank you.